Hello everyone, myself Kushal. I am a student of Sri Venkateshwara College of Engineering. Today we are gonna discuss about Gauss divergence theorem. Next, introduction to Gauss divergence theorem. The Gauss divergence theorem is a fundamental concept in engineering physics. Also known as Gauss theorem, it relates the flux of a vector field across a field surface to the divergence of the field within the volume enclosed by the surface. This theorem helps in understanding the behavior of vector field and their source or skins within a closed region. The divergence theorem of Gauss. Trivial integral of vector del dot f d dv, which is equal to double integral by s f dot n to the n into ds. Statement of Gauss divergence theorem. The integral of the normal component of the flux density over any closed surface in an electric field is equal to the volume integral of the divergence of the flux throughout the surface enclosed by the surface. The vector operation del and the divergence theorem. Next one. Understanding the flux and divergence. Flux represents the flow of movement of a vector field across a surface. It qualifies the amount of the field passing through the surface. Divergence, on the other hand, measures the rate at which the vector field is spreading out or converging at a point. The Gauss divergence theorem relates these two concepts, showing the divergence how the divergence within a volume influence the flux across the surface. Flux a vector field via open surface depends flux depends a on the magnetic of the field, on the area, on the relative orientation. Simple case. Orientation is constant with respect to the surface vector. Magnitude of the field is constant over the surface. Phi is equal to integral power e cos theta into dA. Phi is equal to e power cos theta to integral power of dA. Phi is equal to e of cos theta into a. Next one. Applications of Gauss divergence theorem. The Gauss divergence theorem finds the application in various areas of engineering physics, including fluid dynamics, electromagnetic, and heat transfer. In fluid dynamics, it helps in the analysis fluid flow through control volumes and understanding the behavior of fluid source or skins. In electromagnetism, the calculating the electric and magnetic field strength across closed surface and studying charge or current distribution. Gauss divergence theorem. Gauss divergence theorem helps to transfer a volume integral into surface integral. It states that the volume integral of the divergence of a vector field V taken over any volume V is equal to the surface integral of V vector taken over the closed surface surrounding the volume vector. Next, simplifying calculations with Gauss divergence theorem. Gauss divergence theorem provides a powerful tool to simplify calculus involving vector fields. Instead of evolving the surface integral, which can be complex, it allows us to directly evaluate the volume integral of the divergence. This simplifies the analysis and enables efficient calculations in engineering physics applications. Illustration of the Gauss divergence theorem. Let's consider an example of the fluid flow through a closed surface. By applying Gauss divergence theorem, we can relate the flux of a fluid through the surface to the divergence of the fluid velocity within the enclosed volume. These relations help to quantify the flow rate and study the behavior of fluid sources or skin within the region. The Gauss divergence theorem, integral theorem. This theorem permits the express certain integral by mean and surface integral. This theorem related to close a volume vector in a space and the surface bounded with vector function position A. Del dot A, which is equal to dou of Ax divided by dou x plus dou of Ay divided by dou y plus dou of Az divided by dou x. positive side assumed. Next one. Finally, conclusion. Gauss divergence theorem is a critical concept in the engineering physics connecting the flux of a vector field across a surface within the divergence of the field within the enclosed volume. It simplifies, calculates, and aids into analysis various phenomena, including fluid dynamics, electromagnetism, and heat transfer. Understanding and applying the Gauss divergence theorem is essential for engineering and physics working in divergence. Thank you.